All right, let's talk about permutations and combinations. Here we go. Let's actually jump in with number 1, and it says, in how many ways can a first and second place winner be chosen from a contest involving 5 people? So we're going to have 5 people, and we need a first place and second place winner. And if I have 5 people in this contest, then I'm going to have, well, 5 options for the first place winner. So 5 options for the first place winner. And once you have chosen a first place winner, then you're going to have 4 options for the second place winner. And we're going to multiply this together. If you wanted to, you could make a little tree chart and it would be fantastic. And it would really be 20 ways. So no surprises there. But things are going to get a little bit crazier. So you might notice that there's a big chart on the top, and I have ignored it. We're not going to ignore it for long. Let's go to number 2. There are 5 students in a classroom, and the teacher needs 2 volunteers. So it looks like the same kind of problem. 5 people, and we really need 2. 5 people, we really need 2. Okay. And how many different groups of volunteers? How many different groups of volunteers are possible? Well, now it's different. Okay. Here, the order matters. Like, it matters who's first and it matters who's second. And here, the order doesn't matter. So let me bore you to death for just a second with a pen over here. If I have 5 different people, A, B, C, D, and E, and I want to know how many different groups of volunteers are possible, and the order doesn't matter. Like, I can have A and B in a group, or I can have B and A, and it's really the same group. Okay. So 5 different students in a classroom. I need 2 volunteers. So I could have a B in a group. I could have a C in a group. I could have a D in a group, and I could have a E in a group. Now, let's keep going with this. I could have BC in a group. I could have BD in a group, BE. There's kind of a system to what I'm doing, but don't panic if you don't notice the pattern. I could have CD in a group and CE in a group, and I could have D and E in a group. Now, again, we could be like, you know what? I don't want BD. I want DB. Well, it's the same thing, right? So the final answer to this one is actually 10, and I'm going to go ahead and just put 10. But now things get a little different. So like, what if they would have said there are 25 students in a classroom and a teacher needs 7 volunteers? How many groups are possible? Yeah, good luck with that. Like, we can do this with relative ease if the numbers are small, but when they get big, it gets crazy. And there's a really massive formula for it. We're not going to really do much with it. And again, notice I didn't put first place, second place. The order does not matter here. So here goes back to the chart up at the top that we haven't talked about yet. This is a flow chart that explains what to do in word problems like this and when. Is there a larger group put into a smaller group? And in the problems that we've done so far, the answer actually has been yes. So the problem we just did, there were 5 students in a classroom. I only want 2 of them, right? So large group put into a smaller group, yes. And then, is the order of the small group important? And another question is like, are they ranked? Do we have some sort of ranking to them, first, second, third? Or maybe they have specific offices they hold, like president, vice president, or supreme commander of the universe, or whatever. Those kinds of things. So order is, large group put into a small group, yes. Is the order important? And no, for this one, it's a no. So we're going to use a combination, and we're going to put a large number first. So this is the difference between 2 words that you're just now meeting, permutation and combination, although you have probably heard the word combination before. I'm sure you have. Actually, and here's the problem. Most people think of combination and their definition is wrong. Okay, so if you have a combination lock, and you don't have to draw this, but if you have a combination lock, then you have this thing and it goes like that. And if you put the numbers in the correct order, then they will unlock this. That is why this should be called a permutation lock, because the order of the numbers is important. Another math teacher told me that one time, and I was like, ooh, that's really good. Why they call it a combination, I don't know. Because in a combination, the order is unimportant. They're not in any specific order. So now the question is, how do we get this 10 if we don't list everything? So I'm glad you asked. Let's do it. Put my paperweight down right up here. I'm going to share what's on my screen. It's going to be an awkward transition for a second here. And as I do, let me talk about what's about to happen. We're going to go to desmos.com/graphing calculator. And we are going to do, well, a combination. And we always put the large number first. So here goes. I'm going to click, notice where the mouse is. I'm going to click where it says Show Keypad. And I'm going to go to Functions. And we are going to click on Stats. And everything you need is right here in CR and in PR. I'm dealing with a combination, so we're going to click that one. And you'll notice what pops up here. Now, the problem that we just did, number 2, we had 5 students, and we really want a group of 2. So put a 5, comma 2, and then the answer is 10. Now, there's a really fancy formula that cranks this out. It involves some really cool stuff. Love to go into it. That's not the purpose of this video. So this is what we do. Now, the obvious question is, what does the N mean? What does the R mean? Those are variables that were kind of an older representation of this before we really had the technology to do it the way we do it. But the notation stuck around. So in CR for combination, in PR for permutation, and that is a 10. So we're going to go to number 3, and I'm going to stop sharing my screen. There we go. So I'm on number 3 now. How many different ways can the top 6 American Idol contestants be ranked? Okay, let's grab a red pen and underline some stuff. Ranked. This tells me that the order is important. So how many different ways can we rank the top 6 from a field of 12 contestants? So I have 12 people and I only want 6. So let's go to the flow chart. Is the large group put into a smaller group? Yes. Is the order of the small group important? And the answer is yes, because we're going to rank them. So we need to use a permutation. We'll put the large number first. So I'm going to write it the way it appears on Desmos, not the way it appears in textbooks or in some of the more sophisticated notation. All right. So the previous problem, just because I want to write it like this, was this. Okay, this is not the mathematical notation, and I don't know where I got that 10 from. That should be a 5. My apologies. There it is. Okay, and we got that answer. Now for this one, it is a permutation. Again, the N and the R, it's kind of an older way of representing it. It was wonderful, but now our technology just represents it differently. And we had 12 American Idol contestants. We only wanted 6. And then we're going to crank out an answer. Now, by the way, there is another way of doing this. We'll get there in a second. Let me share my screen once again. And when I do, I'm going to go to desmos.com/matrix. No, not matrix, sorry, old habit. I'm going to go to desmos.com/calculator, and there it is. So I want to use a permutation. So we click Functions, we click Stats, and it's in PR. Now, if you wanted to, you could just type it. Just make sure your capitalization is correct. 12, comma 6. And that's it. 665,280. I'm writing it down. And I will stop sharing my screen. I am not going to go back to Desmos on this video anymore. Now that you know how to access these things. Again, click the keyboard, go to Functions, you click on Stats. However, again, if you want to, you could just type it. You could be like in capital P R, and then you do, you know, whatever, 12, comma 6, and it'll do it. So you don't have to go through that process. You can just type it, but the middle letter needs to be capitalized because that's the notation. All right, so here goes. Stop presenting my screen. We'll go back here. There we are. All right, let me show you another way we could have done this, but it's not the most efficient way. So I could say, well, you know what? We're going to have the best contestant, and we have 12 possible candidates for contestant number 1. And then we're going to pick the second best, and we have 11 for that. And then we're going to have 10, and then we're going to have 9, and then we're going to have 8, and then we're going to have 7, and then we're going to stop because we have just ranked the top 1, 2, 3, 4, 5, 6. This is that. It's the same thing. This is faster. So we could have done that on number 1. So let me just go up here for a second. Another way of doing number 1 would be, oh no, I have a permutation. I have a first place and a second place. The order does matter. And my in PR, 5, comma 2 would give me 20. It's another way of doing it. Okay, now that we've sort of done an overview of it, let's go a little faster through the rest of these. Number 4, how many different subcommittees, let me get my paper straight here. How many different subcommittees can be made from a committee of 5? There will be 3 people on a subcommittee. And this one actually is going to bring out a really cool concept. So here goes. Do we have a large group that's being put into a smaller group? So 5 people becomes 3 people. And the answer is yes, we do. Large group put into a smaller group, yes. Is the order of the small group important? Well, let's see. The different subcommittees, they're not ranked. It never says you're going to choose first place, second place, third place. There's none of that stuff. So it's just a group, right? Just a group. So this is going to be a combination because the order is not important. Put the big number first. So in CR, with the big number first, 5, 3, and you go to Desmos. I'm not going to do it now. You can type that in exactly the way it looks. You can click the little functions if you need to. There's a way to do this on a graphing calculator as well. You get a 10. All right, I want to point out something here, and this is going to happen again in a minute. Notice these are the same answer. So if I have 5 people and I want a group of 2 or I want a group of 3, then we have 10 possibilities. And the reason why is this. For every group of 2 I have 3 more that aren't in that group, which could be their own separate group. Let me say it a different way. And the math behind it with the formula that we're not going to do in this video, the math behind it really works out very neatly, but it's this. The 2 plus 3 gives me 5, and these answers are going to be the same. That works for a combination. I wonder if it works for permutation. Interesting. That was an answer that I know the answer to, but I'm not going to tell you. Mrs. Bell's mathematics class consists of 6 sophomores, 12 juniors, and 10 seniors. How many different ways can Ms. Bell create a 5-member committee of seniors if each senior has an equal chance of being selected? Okay. Big group made smaller? Yeah, because I have a bigger class and we're only going to have 5 on a committee. But here's the trick. I have too much information here. This is about seniors. This is not about sophomores. This is not about juniors. So just read it carefully. Okay, so what we really have is 10 that becomes 5. We'll go ahead and write that in purple. I don't know why. 10 becomes 5. And then I'll read it again and I say, well, you know, I put a big group and made a smaller group out of it, but am I ranking them? And the answer is, well, it's a committee, and they never said first place, second place, third place. So this is in CR. And so I would just simply type that into Desmos, which is actually what I'm about to do on my calculator now. Give me just a second. Feel free to go ahead and type this into Desmos. I got an answer. Got 252. There we go. There are 252. I could list the first 10 letters of the alphabet and then start putting them in groups of 5. If I did it correctly, I'd have 252 groups. Okay, a few more problems. And now we get into problems that have very few numbers in them. And we are going to do 6 and 7 at the same time. This episode is brought to you by... No, this problem is very similar to the movie Toy Story 3. You have a collection of toys you're going to donate to Sunnyside Daycare. Let's start counting. Buzz, Bullseye, Jesse, Rex, Mr. Potato Head, Mrs. Potato Head, Ham, Slinky Dog, and 1 green alien. If you've seen the movie, you know there's more than 1 in the movie. That's okay. I don't want to complicate things by having identical toys. That goes into a realm of mathematics we're not going to play with. So let's just let there be 1 green alien. So if we counted them all, there would be 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 4 of these toys are going to be placed in the butterfly room, and the rest will be in the caterpillar room. So the other 5 will be in the caterpillar room. How many different groups of 4 are possible for the butterfly room? So here we go. Big group made smaller for sure. If you've seen the movie, you'll know that. Big group made small. Actually, I think they all went into 1 room, but that's beside the point. Big group made smaller. And so the group is 9, and we're only going to have 4 in the butterfly room. But now the question is, are they ranked? And the answer is, well, no. Now, how do you know they're not ranked? Because they never said anything about the order mattering. They never said things like, here, I'm looking at number 9 right now, president, vice president, secretary. That's important. They never said things like, I'm looking for another one, how many different orders. So the order would matter in that case. They never did that. So it's just a group of 4 toys. You put them in the room and they all play fair and they play nice. So this is a combination, NCR 9,4. And so we shall figure that out. I'm using my calculator. I'm not going to Desmos. It's a little cumbersome for me to switch screens and do that. Let's not do the next problem. Well, let's do it, but let's not do it. I don't feel like doing it. I mean, we're going to do it, but you know what I mean. So here goes. Group of 5. Guess what? I'm not going to do it because I've already done it. Here goes. If I was to list all of the ways that I could have a group of 4, then every time I have a group of 4, then I have 5 more that aren't in the group. So I would have the same number of ways. All right, let's keep moving. Pizza shop has available toppings of pepperoni, onions, peppers, I'm getting hungry, bacon, olives, sausage, mushrooms, anchovies. How many different ways can a pizza be made with 4 toppings? Is this a big group made smaller? Well, 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have 8. I want 4. I have a big group made smaller, so let's just go ahead and do the 8,4. But now the question is, does the order matter? They never said it did. It never did. So no, it doesn't. Like when you order a pizza, you don't say, all right, I want the pepperoni first, and then on top of that, I want the onions. I mean, you might, but then they're going to be like, who's getting this permutation pizza? You don't want a permutation pizza. You want a combination pizza. Just throw it all on there. So there you go. NCR 8,4. And I have 70. By the way, well, never mind. I was going to say if you had another problem that had a 4 here, well, of course it would be the same. But whenever they add up to be that first number, they're the same in a combination. Again, I wonder if it's the same for a permutation. Not going to say. The debate team at Lincoln High School must choose a president, vice president, and secretary. All right, let's count. That's 3 things. If the team has 14 members, how many ways could the officers be chosen? Big group made smaller. Big group made smaller? Yes. Is the order important? Yes. They gave you a list of officers. So what we are going to do is put in PR, and I had 14, but I only want 3. And so we'll figure out the answer. Now, by the way, if you really care, and you may want to care, you may want to write this, I could have a president. Oh, I have 14 options. I could have a vice president. Ooh, I have 13 options. I could have a secretary. I have 12 options. This is another way of doing it. But if this would have been like 14, 12, like who wants to type all those? Like 14 times 13 times 12 times 10 times 11, you know, not worth the trouble. 2184. All right, let's slide up. We have 3 more problems. The debate team at Perquimans High School must select a group of 3. Has 14. How many different groups? All right, you figure this out. Feel free to pause the video. Does the order matter? I awkwardly paused on purpose. Big group made smaller for sure. The order, does it matter? It didn't say. And so because the order doesn't matter, then I am going to put a C right here. All right, so we're going to go ahead and figure that out in the calculator. And when we do, we'll have 14 and 3. 364 right there. All right, 2 more. This is a tricky one, so we have to really be careful with this one. 6 people are hired as an assistant to work at a kitchen at a local restaurant. 2 are going to wash dishes and 4 will cook. So first of all, we have 6 people, but we're going to break them up into groups. So again, if we're going back to our flow chart, large group made smaller, yes. is the order important? So if you read the whole problem, you'll notice they never said like there was the main cook and then the secondary cook. No, just 4 people in the kitchen cooking. That's it. 4 people, 2 people washing dishes. There was not a ranking. So the order doesn't matter. So this one's going to be a combination. And now that the question really has to do with this idea and this idea right there. And it's the fact that if we have 6 people, here we go, NCR. It took me way too long to write that C. I had to stop and think. NCR, and I have 6, and I want 4 to cook, then it's the same thing as if I want to know the combination of 2 cooking. It's the same. So how many different ways can these workers be assigned this task? Same thing either way. So here goes, gonna figure it out. I got 15. Again, beautiful formula. All right, here we go. Tricky one. So easy, it's tricky. There are 4 mannequins at a clothing store. How many different orders can these 4 mannequins be arranged? Is it a big group made smaller? No, it's not. You have 4 mannequins, and you're going to just set them up. You're going to set up a first, a second, a third, and a fourth. I have 4 mannequins. Well, I have 4 options for this one. I pick a mannequin. Now I have 3 options. Then I have 2. Then I have 1. And I'm going to multiply all that together, and I have 24. Now, you're probably like, but the order is important. Yep, it's important. But the big idea was this. Is there a larger group put into a smaller group? No. Just multiply your options together, which is exactly what we did. Now, you've seen this before, but just in case you forgot, if you have 4 times 3 times 2 times 1, you could have represented it as 4 exclamation mark, which is known as 4 factorial. Not super practical unless the number is enormous, and then it makes it a lot easier. So 4 factorial is also 24. That's the equal sign. It's just really long. All right, there you go.